Good evening, everyone, and welcome to today's workshop. So today we will have the second day of this marine data for Baltic Sea. So this is a Copernicus Marine Service workshop, and today we will have our practical session. So as you might remember, 2 days ago, we gave you an introduction to the Copernicus Marine Service and what sort of data you can find in the service and what we provide in terms of global data. And we also provided some example on how you can use the data for the Baltic Sea with external use case speakers. And today we will have a more practical session, so we will show you how you can visualize the datasets and how you can apply it to a case study with tutorials. So before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible way. So first, please do not use the chat that you see on your right-hand side for your questions. You can use it for small talks and talk between each other, but if you have a more technical question, or if you have any other question, we will use the Q&A section on the website that you can find right here. So please put your question here and we will answer them during the Q&A section dedicated. And speaking of our speakers today, so we will have 4 presentations. So the first one will be from Leila from Mercator Océan. She will present the Copernicus Marine Toolbox, so a very useful tool to download data and other things, as you will see. We will also have a presentation of Alvaro, the Pascal Collar from Now Systems. So he will do both the Jupyter Notebook tutorials and the Air Studio tutorials. And finally, we will have Stefania Celiberti, also from Now System, who will do the QGIS tutorial. So as you might know, and as you might have seen, at the top bar of the event page, you will find 3 tabs. So one dedicated to the Jupyter tutorial, one for the Air Studio tutorial, and one for the QGIS tutorial. So I hope you had time to explore these exercises and now have some questions for Stefania and Alvaro. So yes, we will move on then to the first presentation. So so Leila, whenever you want, the floor is yours for the Copernicus Toolbox.
Okay, thank you. Hello, everyone. Okay. So, all right. Today, I will introduce you to the Copernicus Marine Toolbox, our new data download tool. So the Copernicus Marine Toolbox is a free user-friendly tool designed to interact with the Copernicus Marine data store. This tool allows many possibilities. With it, you can view and extract the metadata. So they are detailed information on all the variables, the data sets, and the products. You can also download subsets of data sets, meaning that you extract only the part of the data that you want. You can use filters that will help you getting specific data files via direct connection to the Marine data store. And finally, with the toolbox, there is no limit, either for data volume or bandwidth. So in short, the toolbox lets you explore and download all the products available in our catalog without any quota restrictions. One of the advantages of the toolbox is its ability to download data with a significantly improved performance, and this is due to the conversion of all the data sets to the analysis-ready cloud-optimized format, so the ARCO format. Analysis-ready means that the data have been homogenized for ease of use and the interoperability for both time series and geospatial queries. And cloud optimized indicates that the state-of-the-art technologies are used to store the data optimally and to enable fast parallel access to the data. The Copernicus Marine Toolbox offers these new access services via the ARCO GeoSeries service, the ARCO Time Series service, and the Original File service. So the GeoSeries service provides a version of the data with a small chunk size for the time dimension and a large chunk size for the longitude and latitude dimension. So it is optimized for analyzing large geographic domains over a short period of time. For the time series service, it's the contrary. The service provides a version of the data with a small chunk size for the longitude and latitude dimensions and a large chunk size for the time dimension. So the service is optimized for analyzing complete time series over a relatively small area. And then the original file service provides the original version of the data as delivered by the producers. So during this presentation, I'll show you the main functions of the toolbox, and I'll also show you some examples so that you can see how quick and easy it is to use this tool. So the main functions of the toolbox are the login function, with which you can automatically create an encrypted file that will contain your login details. There is the describe function, with which you can retrieve the metadata of the products and of the datasets. There's the get function with which you can retrieve and download the original data as delivered by the producers. And there's the subset function with which you can retrieve and download only the part of the dataset that interests you. So Toolbox can be used both on the command line interface, such as the Mamba's Miniforge prompt, and on a Python interface, such as the Jupyter notebooks, or by using an editor like Visual Studio Code. So let's start at the beginning and visit our Help Center. It is accessible from the Copernicus Marine Service homepage by clicking on User Corner and then on Help Center. So in the Help Center, this is where you will find all the information about our different services. To learn more about the toolbox, you just have to scroll down and click on Copernicus Marine Data Download. Then you scroll down again and you click on Copernicus Marine Toolbox. So you can see that we have published 31 articles about the toolbox. In the Getting Started with the Toolbox section, you will find some of the information I've told you about at the beginning of the presentation, but there are two important articles. The installation article, because in this article, we develop the steps you need to follow to install the toolbox correctly in your machine. And there is the credentials configuration article, in which we explain how to use the login function of the toolbox. In the main functionality section, you will find articles for each of the toolbox function for both the command line interface and the Python API. In the use cases section, you will find article that explains how to use the toolbox for specific situation, for example, how to get data for a recurring period. And we also explain how to use the toolbox with other softwares and other languages like R and Julia. And finally, at the beginning, you have the troubleshooting and FAQs section. So if you encounter a problem with the toolbox, you can check the troubleshoot article, in which we address many issues that can happen. And we also give some solutions so that you can solve the issue on your own. If you have a question about the toolbox, I recommend you to check the FAQ article, in which we have answered the most asked questions. If you want to report an issue, or if you want to request a new feature for the toolbox, you can check how to do that in this article. And you can check the past and future improvements of the toolbox in this article. So for this presentation, we are going to pretend that we have already installed the toolbox by following the instruction from this article. So it means that the toolbox was installed in an isolated Python environment. So from there, the first thing that we need to do is to open a command line interface. And this is what we are going to do. And in this case, it's the Miniforge prompt. So we are going to activate the environment by running the command mamba activate Copernicus Marine. By doing so, we are no longer in the base environment, but in the Copernicus Marine one. And now we are going to check which version of the toolbox is installed. To do that, you call the toolbox and you write the version argument. And we can see that I have the latest version of the toolbox installed, version 133. Okay, so I'm going to show you the first toolbox function, the describe one. With this function, you can retrieve the metadata from the Marine data store. We are going to check the options you can use with describe. To do that, you just have to run and to call the toolbox, then write the name of the function describe, and then you add the help argument. So by doing so, you can see all the options on the left, and on the right, you have the description for each of the options. For this presentation, unfortunately, I won't have the time to really talk about all the functionalities of Describe, but you can check our help center. Everything is explained there. Now I'm going to talk about the second function of the toolbox, so the login function, with which you can create an identification file that will contain your username and your password so that you won't have to type them every time you want to download data. You need to know that the login function only need to be used once because then your credential will be stored on your machine forever. So to use it, you just have to call the toolbox and then write the name of the function, Copernicus Marine login. Then you write your username and your password. Be careful when you write your password because the writing is hidden, so try to not make a mistake. Then you can see that our credential file is stored in the Copernicus Marine directory. And if we check this directory, we can see the credential file is here. Okay, and this is it for the login function. This is the only thing we can do, but it's an important thing. Now we are going to look at the get function of the toolbox. With this function, you can download original data as delivered by the producers. So we are going to check the options we can use first with get. We call the toolbox, we write get, and then we add the help argument. So you can see that many options are available with the get function, but only one is mandatory, and it's the dataset ID one, because we need to specify at least the dataset from which we are going to extract the data. So we are going to choose the dataset. To do that, we are going to go to the Copernicus Marine homepage here. We are going to click on ocean products and we are going to choose a Baltic product, so this one. Then we are going to click on data access and you can see all the data sets available in the product. We are going to choose this daily data set and copy it. So to download data from this data set, we have to pull up and call the toolbox, then write the name of the function, write the mandatory option, dataset ID, and we are going to pass the name of the dataset. So we could run the request as it is right now, and this would retrieve all the data for this dataset. But today I want to show you how to download data for specific dates. For example, we are going to download data from the 1st of September to the 3rd of September 2024. To do that, you just have to add the filter option and then you write the dates. So 2024 September from the 1st to the 3rd, like this. And we are also going to add the output directory option. With this option, you can indicate where you want to save the data. So now I have to write the path. Users. Okay, I'm going to save the data in the data directory, and then you can run the command. Okay, so we can see that the toolbox has retrieved the three files we wanted for the 1st, the 2nd, and the 3rd of September. It is asking if we want to proceed with the download. So yes. And you can see that when we run the request, we got these info messages. So they are giving us information about the dataset version used, the dataset part, the service that was used. So for the get function, it's only the original file service. And then we have messages indicating that the download is starting. So now the download is done. We are going to check the data directory. And you can see the 3 files are downloaded here. All right. So there are many other functions you can use, options you can use with the get function, but I won't have time to see all of them today. But as I said it before, you can check the help center to learn more. Now we are going to see the subset function. With this option, you can extract only the part of the data you want from a data set. Since the beginning, we've been working on the command line interface, but now I would like to show you how to use the toolbox on a Python interface. You will see that the syntax between the both is different. Personally, I will use Visual Studio Code, but you can use the editor or the program of your choice. So let's open Visual Studio Code. Then let's open a new file as a notebook. Make sure that you select the kernel corresponding to the environment on which the toolbox is installed. So for me, it's the Copernicus Marine one. And now you are ready to use the toolbox in the notebook. So the first thing we are going to do is importing the toolbox with import Copernicus Marine. All right. And now we are going to check the options available with the subsets function. So on the command line interface, we were using the help argument, but with Python, it's a little bit different. To do that, you have to call the toolbox, then write dot the function, so dot subset, and then you add a question mark. And by doing so, you can see all the options you can use with subset. So now we are going to build our first request to download data with subset. Usually we recommend to our users, beginner users, to use the subsetter. That way they won't make a mistake in their request. And this is what we are going to do today, actually. So let's go back to the product data access tab. We are going to use the same data set. And to access the subsetter, we just have to click on the form button. The subsetter can be used to download data directly from there, but you need to know that there is a size limit. And you can also use it to build requests for the toolbox in an easy way. So first you have to select the different parameters. So the variable, I'm going to choose the temperature. You have to select the area of interest, the date range. I'm going to download 3 days of data, and the depth range, but I'm not going to change anything. Then you click on automate, and you can see that you have a request for the Python API and for the command line interface. So I'm going to copy the request and then pass it in my notebook. So we could run the request as it is right now, but I'm going to add some options. First, I'm going to add the output directory option so that I can indicate the path to where I want to save the data. Data, all right. Then I'm also going to add the output file name function. That way I can give a name to the file I'm going to download. I'm going to call it Baltic .nc. And I'm going to add the force download option. So with this option, you can skip the confirmation message before the download. I just have to specify that the value is true for this option to work. And we are done. We can run the cell. and the data is already downloaded. We just have to check the data directory to find our data file right there. And now we are going to see the latest features of the toolbox. So the open dataset one and the read data frame one. So with this function, you can remotely open data without having to download them. So let's start with open datasets. We are going to check the options available. Copernicus Marine dot open dataset question mark. And you can notice that the options are almost identical to the options of the subset function. To show you that they are very similar, I'm going to copy the subset request, paste it, and I'm going to replace subset with open dataset. I'm going to remove the three options, output directory, output file name, and force download, because these are options you use when you want to download data, and this is not what we are going to do right now. We are going to open them remotely. And I'm also opening the data in the variable ds, so ds for datasets. Okay, I run the cell. And now you can see the data remotely opened. You can do whatever you want with the data. And once you're done working with them, you can save them. You just have to indicate the name of the variable. Then you add the toNetCDF function, and you write the name of the path to indicate where you want to save the data. So I'm going the path I already wrote here. Okay. And you also have to indicate the name of the file. So I'm going to call it remote data.nc. And then you can run the cell. And in 1 second, you can see that your data was downloaded here. And for the read data frame function, it works the same way as an open data set, except that it displays the data in a data frame. So it can be very useful when you want to open the data in the CSV format. You just need to know that the data is no longer displayed with the XRA package, but with the pandas package. So it is strongly recommended to create the subset before opening the data. Otherwise, you will receive a message telling you that the data is too large for this format. So we are going to copy the content of the open dataset cell, paste it, and we are just going to replace open dataset with read data frame. Okay, you run the cell. And now you can see your data displayed as a data frame. Once again, once you're done manipulating the data, you can save them with the toCSV function. And then you have, once again, to specify the path and the name of your file. So I'm going to call the file the same way, but I'm just going to change the extension so it's a CSV file. And in the data directory, you can find your CSV file. All right, now we've explored all the functions of the toolbox. You need to know that at present, not all the products in our catalog are available via the subset function. In fact, if you go to the Copernicus Marine Service homepage, then you click on User Corner, and then you go to the User Notification Service. Our force notification, this one indicates which dataset is available with the subset function of the toolbox. You can check this table and you will see all the details. If you have a question or if you have a problem, I would suggest you to check the help center. But if necessary, you can contact us by clicking on this widget, then on messages and ask a question. First, you will be talking with Blue, our AI chatbot, but if his answer is not satisfying or if you really need to talk to a real person, there will be a talk to a person button. You just have to click on it and you will be talking with a member of the user support team. All right, I'm done with the presentation now, and thank you for your attention.
Thank you very much, Leila. It was a really nice presentation. So we have a few questions for you.
All right.
So the first one is more of a general question, so I will answer it. So someone is asking where and how long will the recordings of this workshop will be available. So the recordings will be available in like 1 week or 10 days time approximately. You will receive an email when you can see the replays and the PDF presentation. And otherwise it will be available as long as you want on YouTube and on the webpage even. So don't worry about that. Okay, so we have two questions from Urias. So the first one is the toolbox web-based or standalone?
It is standalone.
Okay. And the other question is if you can use the toolbox without prior knowledge of Python. So as you show, you can see the different function, but yeah.
Yeah, you can use it on the command line interface if you don't want to use Python. But even if you use it with Python, I don't think it should be too hard because we have many articles on the help center and all the steps are explained. So you can just follow that.
Okay. Okay, yeah, so don't hesitate to check the website if any questions arise.
Yeah.
So someone is asking if they used open dataset function to access data in the cloud, but some datasets are not available with this function. Will these datasets be available later?
Yeah, yes, they will be available later. As I said it at the end of my presentation, not all the data sets are available with the subset function. And so the subset function, it's the same thing, almost the same as the open dataset one. But yes, you can check the notification and one day they will be available.
So very soon.
Yeah, we hope.
And so for now, it's the last question is to know if open dataset is as efficient as the get function. In most cases, I do not want to download data.
So the open dataset function is not the same as the get function. So the get function is to retrieve and to download the original data, and open dataset is to open data from a dataset. So they are not the data delivered by the original data delivered by the producers. But open dataset is really efficient if you don't want to download the data, because with get, you are going to download the data.
Okay. Thank you. So a question that we have several times is if there will be, yes, are you planning a R library with similar function as the toolbox? So I don't know if you do.
I don't know.
We will have to check. I think
Yes.
this Copernicus toolbox is quite new already, so maybe we will have a little bit of a delay between the...
I'm just being told by my colleagues that it's in the process. So
Okay.
there will be
Okay.
this.
Very soon also. And so this one is a general question about the certificate of this workshop. It will be at the end of this session, like 1 hour after the end of the event. You will receive an email with the certificate of attendance and the link to the survey to answer some questions and have your feedback on the event. So we have no more question. Yeah, I guess we can wait 10 seconds, but I think it must be good for everyone. So thank you, Leila, for your nice presentation.
Thank you.
And for the first presentation of the first day also. So thank you very much.
No problem. Thank you.
So yeah, I guess we will move on to the Jupyter Notebook tutorial by Alvaro de Pascal Collar from No Systems. So Alvaro, whenever you're ready, the floor is yours. Yeah,
Hi,
I
good
see you
morning.
now. Hi.
Well, good morning to everyone. I'm gonna share my screen. I think it's okay right now. Well, in today's session, we are proposing an exercise that consists on an assessment and estimation of the ocean wave energy resource in the Baltic Sea. And to do this, we are using data of waves from Copernicus services. This exercise is proposed in the Jupyter Notebook environment. As you know, here this is the web page of the workshop. Here you can find a tab to access the Jupyter contents. And in this web page, you can find different buttons. For example, here you have a button devoted to register in the Copernicus Marine Services. And this is because to run this tutorial, you will need to be registered in these Copernicus Marine Services. You will need these credentials, and also you will find a button to access the Jupyter Hub, where we provide access to the notebooks of this tutorial. Well, we provide in this workshop access to this Jupyter Hub, where you can get the tutorial and play with the tutorial and learn everything. But maybe for some people, it could be interesting also to download the tutorial to be run the tutorial and run the tutorial into their own machines. So this is the reason of having these two last buttons. These two last buttons, we provide the information you need to download any tutorial, to install the tutorial in your machine, and to be able to run the tutorial in your machine and starting to make changes inside the tutorial so you can adapt every tutorial to your needs, right? Well, accessing the Jupyter Hub, we will find this window that probably if you are related with Jupyter Hub, you will be familiar with this window. Here there is a file browser and also a workspace. And you will notice that you have not direct access to the tutorial. To have the tutorial in the first thing you need is to have the tutorial in your home folder. And to do that, you need to open a terminal and copy the tutorial into your home folder by typing this command in the terminal. We can click on here and try to do the exercise right now. This is the web page of the workshop. And as I said before, to enter the Jupyter Hub, you can click here. Login for this reason is because you need to be registered in Copernicus Marine Services, because you enter using the credentials of Copernicus Marine Services here. And once you register here, you get here where you probably won't have this directory here. I have this directory, and you will have this Jupyter Notebooks directory. Inside this Jupyter Notebooks directory, you will find this tutorial and other tutorials probably, but the one that we are interested in is this one, the Baltic tutorial. So to copy this tutorial in your home folder, you need to open a terminal and type copy -R and V from Jupyter. Bringing Baltic. See? And it's also interesting to note that this final dot is critical. You need this final dot. If you don't use this final dot, the command won't work. And the moment you do this, you will realize that here you start to have a directory, including the tutorial, right? And after that, I have a tutorial already run here. So you can enter into the directory and open this file, IPyND. So this is the Jupyter notebook for those that are not related with Jupyter notebooks. I can tell you that Jupyter notebooks contains a mixing of documentation and also cell codes. For example, here you can find the documentation of this tutorial. And also you can find cell codes like this one. To run a cell code like this one, you can run this cell code by clicking here in the run button up here, or you can run the cell code by pushing Control Enter or Shift Enter. For example, here you can select the cell and run the cell by clicking here. And you can also include some changes in the cell if you want to include changes in the cell, and you can run the cell by yourself. So you have here an environment where you can play and experiment with everything we propose. Well, this tutorial, we are covering different sections. We are going to plot, as we said, we are going to propose a study to estimate the ocean wave energy resource in the Baltic Sea. So here we have some sections that includes an introduction where we explain this expression, which is the expression we use to compute the power density of the waves. And also we are going to learn a basic exercise that will be the plotting of sea wave high and wave period, because as you will see here, to compute the power energy of waves, we need these two variables, significant wave high and wave period. And after that, we will compute the wave power density, and we will make a short analysis of the seasonal variability of wave power. Well, coming back to the presentation. Here, we have learned how to copy the tutorial in your home folder. And as I said before, we are going to compute the power density of waves here from this expression using this expression. And since we need information of sea wave high and also wave period, we are going to propose to do this exercise with two different Copernicus products. For example, we are going to use a Baltic reanalysis of waves. And since we can also do this exercise with the global reanalysis, we are going to do the same exercise with these two products. And also inside of each one of these products, we are going to download these products. We are going to download two different data sets from these products. For first data set we are going to download is this data set that contains the climatology of the reanalysis. So we won't need to download a full reanalysis to obtain climatic results. We are going to download directly the climatology of the reanalysis. And since we are going to use also information of bathymetry in our plots, we have also to download the bathymetric data set of these products for both cases. As you can see here, we are using the Copernicus Marine Toolbox using the subset function that was just before explained by Leila. And we are using the subset function for the Baltic reanalysis and for the global reanalysis. In the case of Baltic reanalysis, we are downloading all the full domain of the Baltic Sea because we are interested in this region. But since in the global reanalysis, we don't want to work with very huge data sets, we have selected this region. So in the configuration of the subset function, we have included the maximum and minimum latitude. And this here, you can see the different results we are presenting in this tutorial. Well, first we are going to plot. Well, we include the plot of significant wave height and wave period, but here I include a plot of power density. And in the plot of power density, we learned how to include some other information, for example, the lines of bathymetry here, for example, because sometimes it is in an interesting information that we can mix with the information of power density, for example, here, and we learn how to include this information, and also we learn how to remove data deeper than certain threshold. For example, for deeps higher than 100 meters, we learn how to remove the data in that regions, right? So we can reduce our analysis or focalize or analysis in the regions where we are interested according to the bathymetry. And after that, since we are working with the mean, the climatic mean of power density, we are going to focusing in the seasonal variability of this power density, and we are going to make two exercises. For example, here we are plotting the monthly mean of power density, so we will be able to get the months where the more energetic months. For example, we will conclude that January and December are the most energetic months, and the less energetic months are probably June, July, and August. And since we have learned how to plot a map, including different contour lines, also we are going to compute the standard deviation of the energy of the power density, and we are going to plot a map of power density in colors, including also the contour lines of the standard deviation. So we will be able to conclude what regions in the Baltic Sea has more resource, power resource, but we will see also what regions in the Baltic Sea has more variability along the year. So we will realize that the Baltic proper and Gotland basin has a maximum of variability, the annual variability. And here I show you, for example, the results we obtain using the global reanalysis. As I said before, since we are working with a global reanalysis, we don't need to focus in a specific zone or region like the Baltic Sea, so we can move to every location of the world. Here, I've selected this huge region in the North Atlantic, including also the Mediterranean and also the North Sea and part of the Arctic, and we are going to make it the same exercise. We can repeat the exercise using a different data set. The interesting conclusion of this, despite of that we can move our analysis to any place of the world, not only the Baltic, is that at the end, as you will see in the tutorial, is that you don't need to change much things to do this analysis with different data sets. So you can do the analysis with this data set, and including few changes, you can translate this analysis to any place of the world or with a different product. So you can compare the results with different products. You can also make a kind of ensemble result mixing different products, etc., etc. Well, this is all for this tutorial. I hope you find interesting information on it, and you find
Thank you very much, Alvaro, for your presentation. So for now, we have only one question. Maybe more will come in the next second. So the first one is if you have a recommendation about how to best access tidal amplitude data, and if this can be covered within the C-surface 8 above geoid variable.
Yeah. It can be actually. We did a workshop on the region of it was the workshop on marine data for Asia. We did an exercise of sea surface 5, and we used different products. We use, if I am not wrong, we use the reanalysis product to get the information of tides, and also we include information of satellite. We use a product of sea surface 5 of satellite.
Okay. Yeah, so we are going to put you the link to the e-learning material pages so you can have a look at all of the past tutorials. Maybe you will find something that can be useful for you, and you will find a very large catalog of different exercises, most of them done by Alvaro also, so feel free to check them. So this question from Urias: is there Jupyter Notebook learned separately from the being used in the exercises? So I'm not sure to understand the question, so I don't know if you do, Alvaro. Otherwise, Urias, you can ask again your question. Maybe you can try to rephrase it differently, because I don't think both of us are understanding it correctly. So
used in the exercise. Maybe.
Is that?
Yeah. Well, I don't know if we are still talking about this question. Well, I don't know if it refers to something related with how to run the tutorial. I would recommend to go over the video tutorial, so there is everything explained in the video tutorial about how to run the tutorial, etc.
Yeah, you can check the full video tutorials, and all of the explanation are detailed on the web page. But yeah, definitely you can use the notebook for another region, as is being asked in the other question. If that's the question, but yeah. So yeah, can this technique be used for other marines area apart from the Baltic Sea? So yeah, as you said, yeah, I'll let you explain.
Yeah. Actually, the tutorial is presented in this way. I think it's interesting to go to do the exercise over the Baltic, because it's an interesting region in terms of assessment of ocean wave energy resource. But since you can change the data set you are using from a Baltic reanalysis to global reanalysis, using the global reanalysis, you are free to go to any place of the world and select the region you are interested in. Actually, in the download functions using the Copernicus Marine Toolbox, the function subset, you will realize that there is some options to select a specific latitude and longitude, the range, the boundaries of your interest region. So it's really simple, actually.
Yeah, it's true. And there is several tutorials on different areas also, but yeah, you can definitely change your study area. So yeah, so that was the last question. I don't know if some of other will pop in the last second, but I think we're good. So yeah, if other questions appear, we will answer them in a post-event report. So we will take a small break. We will be back in 15 minutes, if that's okay for everyone, for the RStudio and QGIS presentation. So thanks again for the presentation, Alvaro, and we will see you for the RStudio tutorial.
Thank you. Bye-bye.
Okay, welcome back everyone. I hope you had a nice break and you had time to grab a tea or a coffee. So we will go to the QGIS tutorial. So it will be Stefania Ciliberti from No Systems. So whenever you want, Stefania, the floor is yours.
Thank you, Gael. Hello, everyone. I'm going to share the screen. Okay. So in this presentation, I'll give you an overview of the main contents that I proposed in the QGIS exercises. That is basically that are available in the user corner in the Copernicus Marine website. So the main scope, of course, here is to give the context on how to use the Copernicus Marine data in the QGIS framework, so in the geographical information systems, more in general environment, and try to understand how to implement the workflows that can help you in identifying or studying some specific processes or computing some indexes for in the Baltic Sea, particularly starting from the tools provided by QGIS. Then I'll conclude with a short summary and some references for you to that have been used for completing the exercises and are really nice contribution in literature about the topics that we are going to investigate. But before starting, of course, as I was mentioning before, you will find all the details in the e-learning material corner under the Copernicus Marine Service, where you will see there are some digital contents on the description of QGIS and particularly the plugins that we are going to use for the exercises, together with a short guide that illustrates the basic steps for developing our exercises. QGIS, you know, is a free and open source software, so there is a wide community behind it that supports the development and the usage of QGIS, and as the Copernicus Marine Service contributes on it through the development of plugins like the one that we are going to use, and I'll show you in a while. And the new website of QGIS gives to you a lot of contents and information about the last available release, and as well as the long-term release that both, I mean, together with the last version of the QGIS, I used for developing the exercises. And QGIS can be installed through a standalone installation mode. So basically, downloading the executable that is quite I mean, is serving basically different operating systems. So my exercises have been run on under Windows operating system, but of course you can run and of course install and run the exercises also in other operating systems like Linux or Mac OS. And on the other side, if you would like to exploit some more advanced solution, you can have the OSGeo4W installer that is recommended, especially when you would like to test simultaneously different versions of QGIS without somehow getting in conflicts because of the versions. So as you see, there are many, I mean, there is a quite robust offer in such sense if you would like not only to develop to use QGIS for any kind of applied research context, but also for developing new tools. Now going more on the topic of this training session, of course, the scope here in this event for marine data for the Baltic Sea is to exploit the Copernicus Marine Data Service and so the associated products for monitoring some specific processes at regional scale. And the workshop covers a number of related topics. Particularly in this exercise, we are going to see some application for wave energy, wind power that have been somehow also touched by Alvaro in his previous talk. But of course, I mean, since can be of your interest also as raised before during the Q&A session, and Hasgael did nicely introducing the training session. Of course, we had also issued other training sessions that talks about technicalities on the usage of the different tools, spanning different on different topics like the calculation of anomalies and the analysis effects on regional scale, as well the understanding of physical and biogeochemical condition in specific rivers, or assessing the ecosystem health, increasing the awareness on coastal environments. So all topics that together with the characterization of physical condition in coastal dynamics have been analyzed in other training sessions. So you could also take a look on that and try to give the context also in the Baltic Sea, I mean, for the specific processes that you are interested to analyze, and as well check other kind of or techniques that have been described to manipulate and process the Copernicus marine data. As I was mentioning at the beginning, Copernicus Marine Service contributes to QGIS through a plugin that is suited for basically ingesting the NetCDF data that you have learned how to access and download through Leila's presentation. And this is a quite straightforward plugin because through a graphical user interface gives to you the different steps for loading the NetCDF, browsing through your working environment, your working folder, selecting the specific variable that you want to visualize as a layer in QGIS, and then assigned to hit a specific group in the QGIS environment, and then display in the map layer, as I'll show you in the next slide. So all these, I mean, how to install and configure the NetCDF plugin is also part of the material that has been shared through the dedicated web page in the for this training session. Now, the particular, I mean, here, the scope of this training is to, given the background of the Baltic Sea as a reference domain for our analysis, the major objective is to understand how to use QGIS for extracting some relevant information and exploit its geoprocessing tools for computing some interesting metrics or indexes that can help the everyday life of users that are developing downstream services in the area for analyzing specific variables in the region, from regional to coastal to the coastal scale. So being a geographical information system, QGIS offers this, it's quite powerful to support this kind of activity. And basically, I'm proposing you some exercises on that focus on how to perform some geospatial analysis in support the understanding of the most productive area in the basin from an energetic point of view. So particularly in understanding what can be the most suited area that can ensure optimal production of wave energy. To develop the exercise, I'm using 3 different products, mainly 2 that are based on that are model-based products. So are the Baltic Sea wave analysis and forecast product, as well the wave hindcast product that is produced by the Baltic Monitoring and Forecasting Center. And these data are completed by another type of product, this time coming from the Wind Thematic Assembly Center. So it's we are talking about the wind component from satellite observations that are provided for the global ocean, and that then we are going to subset in the region of interest. Of course, we accessed, as Leila was showing before at the beginning, in general, the reference product through the Copernicus Marine Data Store, and then through some subset function that the Copernicus Marine Toolbox offered to us, I was able to subset the global product in the Baltic Sea region. And indeed, this is basically the starting point of my exercises. So the first exercise, the first example is to understand how QGIS can help in characterizing the physical conditions in the Baltic Sea, for instance, during specific events like the one occurred in October 2023 that is nicely described in this in the paper of Grohl et al. Just recently issued, and that is also included in the reference list. So QGIS, as also described in the document, in the technical report that you can access together with the video through the dedicated web page of this training session, can be used to visualize, in this case, for instance, the significant wave height map from the Baltic wave near real-time system, particularly for the day 20 of October, that was, I mean, one of the days that have been characterized by this storm surge event described in the paper. So you can, through the NetCDF plugin, ingest the NetCDF file and visualize it through the map functioning provided by QGIS. The same can be done for the winds component. In this plot, I show just the U component. And as you can see, and I was mentioning at the beginning, this is coming from the global product that has been subsetted through the Copernicus Marine Toolbox in the area of interest. And of course, as you can see, this is covering both land and ocean. So the step that we need to do, since we are interested particularly in assessing the physical conditions in the Baltic Sea, is to subset the components in the Baltic service domain. This gives to me basically the opportunity to show you how to apply the mask that is provided by the Baltic analysis and forecasting system for the wave component to the wind source provided by the global product. And this is easily done because QGIS, through the raster calculator, support us in doing some simple mathematical expression, implement some simple mathematical expression, like the one that I'm showing here to you. So basically, the idea behind the workflow that we are going to implement is to retrieve the data from the wind product that are corresponding to the region in the Baltic Sea where the mask is equal to 1, in order to retrieve the data only in the ocean domain. And in case, I mean, where we have the mask equal to 0, so where basically the Baltic Sea product has a mask equal to 0, we don't want to, we would like also to mask consequently the information, the grid points in the global wind product. So by applying this formula, the result is displayed in this new map. So I have now the wind component, in this case, just the eastward component in the Baltic service domain. And this helps to, I mean, of course, together with the northward component, help you to, for instance, retrieve some specific, the time series of the UMB component of the winds in a specific location, or somehow overlap the information of the wind with the wave, significant wave height provided by the Baltic system. So This is just an example on the capacity of QGIS that can help you in refining your tools for analyzing and monitoring the region. And I take the opportunity also to show another capacity of the CMEMS NetCDF plugin that is related on the plotting, quite easy, through it, of the map of wind direction. And this is done by selecting basically the two components of the wind provided by the global product, so U and V, and selecting the function vectorize that is provided by the plugin. This function can work also for the currents, and of course you can have the reference in terms of convention. You can follow, in this case being winds, we are following the atmospheric convention, but if you for instance download from the physical product of the Baltic MFC also the currents, you can visualize similarly them through QGIS. And in the training material, you have also the step-by-step explanation of how to do that, how you can customize the palette for the wind direction arrays, and subsampling them in order to somehow adapt the visualization of the surface map depending on the region that you are analyzing at regional scale, but also at coastal scale, maybe in, let's say, decreasing the downsampling automatically done by the plugin. Now going to another topic that gives again the opportunity to show how QGIS works, and similarly to what Alvaro showed in his exercise, also here QGIS can support the calculation of indexes and new variables through the spatial analysis tools. And here there are many references in literature available. I just choose one that is the Lavidas in 2020, this paper that explain quite nicely the context. I mean, since we are interested to characterize from an energetic point of view where are the areas in the Baltic Sea that are characterized by production that can be potential area of wave energy production. I choose these two quantities, the wave energy resource and the coefficient of variation, to show, basically to try to implement them through the QGIS. So you have here basically the wave energy resource formula, P wave, that is expressed as the energy per unit of wave crest width in watt per meter. And as you see, the function is, this variable is depends on the significant wave height and the wave period. That are two products provided by the Baltic wave analysis and forecasting system, but as well as the reanalysis. And on the other side, being the wave energy resource somehow driven by the significant wave height variable, we might be also interested to assess the variability of the significant wave height by computing the coefficient of variation. That is the ratio between the standard deviation and the mean of the significant wave height. How this is done in QGIS? Well, it's quite straightforward, because the calculation of P wave requires, as I was showing you before in the formula, the retrieve of the variables for significant wave height and wave period from the Baltic model-based product. In this case, since we could be also interested, as done in the paper, to make an analysis from a more climate oriented point of view, so using the climatology available in the region, I accessed, as I was listing in one of my previous slides, the Baltic Sea Wave Hindcast product, that is the multi-year product provided by the Baltic Monitoring and Forecasting Center. And in particular, I accessed the climatological dataset that contains both significant wave height and wave period computed on the reference period from 1993 to 2022. And of course, all the details about the product, together with the scientific quality of the product itself, are available through the Copernicus Marine Data Store. So I assume that you have seen how, I mean, through the Copernicus Net CDF plugin, we were able to ingest the data in QGIS for the 12 reference months for the both variable. And then through the graphical modeler, we are somehow supported in identifying or characterizing the workflow that is needed for implementing the formula that I was showing to you before about P-wave. So we need the two raster layers that are the significant wave height and the wave period, and the raster calculator basically is the algorithm that allows us to implement the formula that I showed to you just before, that is at the end resulting in a new layer that I call P-wave. And one of the options that I'm going to basically to describe here in this presentation is to insert basically the formula just in the raster calculator directly. So as soon as you have set your workflow and you click on this green arrow to submit the process, QGIS opens a new graphical user interface that allows you to specify the input layers, that in this case are the two layers previously identified. Type the expression, the mathematical expression that is basically the one that I'm showing here enlarged in this box. And then some other, there are some other settings that by default you can leave as they are, and then address the final result that is P-wave as a, let's say, final layer that you are going to, where you are going to display the result of this mathematical formula. I take the opportunity here to mention that in the document you will see other two options to implement this. That we, in the last weeks, together with the Mercator team, Mercator Ocean International team, we have identified, depending on the version of QGIS, the raster calculator setup might vary. So here the important is to understand, what I want to stress, particularly through this presentation, is to focus on the workflow, in the sense that then you can find a workaround depending on the specific technicalities that the QGIS version is offering to you. But at the end, the concept is always the same. So you can define the formula in the raster calculator as I did, or you can use the graphical user interface that is associated to the raster calculator when you execute it. At the end, we got the same result. We achieved the same result, that is the calculation of P-wave, that at the end can be even somehow complicated by running it in batch mode. The batch process helps us in automatizing the calculation of P-wave, having the formula, applying it to all the layers that we have ingested in QGIS. In this case, we have the 12 months, so for significant wave height and wave period. And we can use the process that we design in the graphical modeler as a core for running it in batch mode. So in one shoot, we calculate all the layers, the associated layers per month related on the P-wave. And here basically is the result as soon as you execute the process as shown in this graphical user interface, and you will get at the end the maps that reproduce also the results that Alvaro was showing to you before. So this is an alternative way, and you see how in this way, complementing the Alvaro's exercise, you see how the Copernicus Marine data are really suited to be used in different platforms in a quite powerful way. Another application, the third example, is the calculation of the variables that are needed for computing the coefficient of variation. for significant wave height. In this case, considering the formula that I was showing to you before, we need to compute the standard deviation and the mean of the significant wave height in the Baltic Sea. So this is basically a way for me to show you another capacity of QGIS, that is the calculation of standard metrics like mean, maximum and minimum value, standard deviation, variance, and so on, that are quite easily done by using the zonal statistics tools. But of course, what we have to do for computing the statistics in any region, and in this case in the Baltic Sea, starting from the raster files that we have ingested through the Copernicus NetCDF plugin, the first step is to convert it in a vector. This step is needed because what I would like to do as final objective is to compute the statistic at basin scale. So in a domain that is, of course, irregular. And being raster, I cannot do that because I need to work with the vectorial layer in order to have an object that is used for computing the metric starting from the physical fields that I have ingested in my QGIS environment. So the first step is to convert the raster to vector, and this is done through the homologous function provided by QGIS. Then, as soon as I have completed this phase, that is detailed also in the technical report, what I have to do is to remove the land so the yellow area where I have the mask equal to 0 from my region. And as soon as I've done this, and I merge all these vectorial layers in one unique through the dissolve function, I get this polygon, this new layer, let's say, that is used then for computing the zonal statistics. So given as an input the reference polygon that I just created through this chain of functions in QGIS, and giving the significant wave height field as a reference, and completing the required fields in the zonal statistics framework, I'm able to compute at the end, as shown in the map on the left, all the statistics, particularly the standard deviation and the mean in the region of interest. And this can be visualized by selecting the table properties. So by doing right click in any of these layers that are, in this case, merged through the merging function, again provided by QGIS, in a table that can be exported in other framework like Excel or Python to finally compute the coefficient of variation as a ratio between the standard deviation and the mean. And then you can plot and try to reproduce the same results that have been proposed in the paper. The last exercise that I was showing to you is to how to use QGIS to support the characterization of the wave energy potential. In particular, in the paper of Nilsson et al., there is the identification and the discussion about the Swedish exclusive economic zone, where it is important to combine the information provided by the service, the Copernicus Marine Service, for getting the characterization of the wave energy potential. So starting from this plot as a reference, what I was able to do, just focusing in one of these region, in one of these area, that is the area related to the Skagerrak-Kattegat Strait. What I did was basically to, first of all, retrieve the data from the bathymetry of the Baltic wave multi-year product, and select only the region where the depth was lower than 150 meters, in order to give the context more at the coastal scale. So this is done how? Basically converting again the bathymetry, the raster, in a set of polygons. Each polygon is characterized by specific value of depth. And in this case, that is how this, here you see a zoom where this is quite nicely reproduced. And then, I mean, what I did was basically to draw the area of interest that is this red area here shown that surround where more or less the areas 10, 11 of the CEEZ region are characterized. By doing filter, I basically open a query builder that is giving to me the opportunity to retrieve all the points where the bathymetry is higher than 0 and lower than 150. And this is the result. So in the region, I have now only the grid points where that are characterized by this value, this range of bathymetry. Of course, I mean, once I have computed this configuration, I need to create a unique object that you see on the left that is basically computed by by intersecting the retrieved bathymetry value in the that is characterized by this specific value of bathymetry below the 150 meter with the polygon that is related on my area of interest. And this is the final result. So at the end, I'm now able to work with this specific object that afterwards, again, by using the dissolve function, I managed to merge in one single, let's say, object that finally has been used together with the physical layer, like the significant wave height and the P wave, to clip the specific fields in the region of interest. And this can be, let's say, used as baseline for computing, for instance, the statistics or any kind of or extracting any kind of information for which you might be interested on, as well as monitoring the specific variables in a specific region, in a more coastal region of your domain. So, conclusions. I mean, there are in this presentation, I show you some general capacity of QGIS in analyzing from a geospatial point of view the Copernicus marine data. We have learned how to use the raster calculator or exploit some more advanced capacity of the model designer for geoprocessing the data, and using how to use zonal statistics for computing some relevant metrics that can help you in monitoring and validating your results. And here, just a brief list of references that I recommend you to read. And that's it from me. Thank you very much.
Thank you very much, Stefania. It was a really nice presentation. So we have a few questions for you. I will just answer the first one, which is a more general question about the re-recordings. So the recordings and the PDF presentation will be available in 1 week or 10 days time. You will receive an email when everything is available on the website, so don't worry. So the first question for you is what particular parameters that correlate with the ocean health? So it was at the beginning of your presentation.
Well, I mean, I'm having this, having the framework of the characterization of the wave energy capacity in the region, of course, this can be used as a baseline for building more complex queries through QGIS. Indeed, one of the applications that I was proposing through the document, I mean, to explore is indeed how to link and correlate other products provided by the Copernicus Marine Service, like the Ocean Color satellite product or the biogeochemical operational system provided by the Baltic Monitoring and Forecasting Center in the area that are characterized, for instance, by higher production of energy, by higher value of P wave. So in this case, you could use the Ocean Color for understanding if the region that are more suited to be productive from an energetic point of view are also area with higher productivity that must be somehow preserved or monitored during the production process, production phase, energy production phase. So this is just to give you some tools to, and then of course, depending on the application, you can find other products in the Copernicus Marine data store that can help you in support this kind of activity like the monitoring.
Okay, thanks. Then we have several questions on the plugin, so I will highlight the first one. So is it planned to make the Siemens NetCDF plugin from the QGIS plugins panel?
Well, this is the approach in QGIS about the external plugins is quite straightforward because as all the other plugins, also the Siemens CDF can be automatically imported through the plugin manager in QGIS, having the name or the source path where this in the QGIS, I mean, as published as QGIS plugin through the plugin manager in QGIS itself, you can retrieve easily the plugin and then make it default plugin in your QGIS environment. But this is as it applies also for the other kind of plugins. This is the philosophy in QGIS, that you can import whatever plugin you have, the community is offering to you, including, of course, this one.
Okay, thanks. So, oh no. So this one is good. So I saw this question on the chat. So is the NetCDF2 QGIS plugin still being maintained? Because I think from what I saw on the chat, in April there was a maintenance. So I think it's back up again.
For this, I don't know really on the Mac what's how it because I just tested in my Windows environment, but I guess that as for the other plugins, if you go in the NetCDF2 QGIS plugin web page, you will find the information about potential recovery of this. But I used the Siemens one, because it's much more easy for our scopes.
Yeah, obviously. Is on the website you can find how to install it to use.
Yeah.
And there is this question, so can the Copernicus Marine data also being used with ArcGIS?
Absolutely, yes. Yeah. We are showing to you QGIS because as for us is our reference tool, but definitely also ArcGIS can be used with the same, similarly in terms of concept. Of course, in that case, you might verify which plugin are more suited for or functions are suited to import the NetCDF, but in principle, the approach is always the same in terms of management of raster and vectorial fields and tools that you can use.
Okay, yeah, that's good to know then. And so this question is about how to use this plugin on macOS. So I think you used it on the Mac, if I'm not mistaken, also.
Well, I did, yes, a trial there, and it's working pretty well. I mean, here the installation, it's somehow the question, if I'm understanding correctly, is referring to the usage of the plugin on macOS that I tested and works, and indeed this is also described in the official documentation of the Siemens NetCDF plugin that is developed by the Copernicus Marine Service. Regarding the installation with OSG or 4W, well, that I installed in the Mac directly the executable because my main machine, the operating system that I'm using for developing is Windows. So I'm not sure really if this the OSG or 4W is, I didn't explore really, and I don't know. I can check and come back to you, but I don't know. It's
Okay.
strange, but the plugin seems to work when you download the QGIS in standalone mode, let's say.
Okay, so I will put aside this question and we will come back to you with a more precise answer. This question, so on the ocean color in the Copernicus marine data, what is directly related to eutrophication, because it was mentioned in your presentation? So I guess
Yeah,
you
I mean,
chance.
yeah, it's true that, with the proposed exercise where have been used just to show basically how to use QGIS. Of course, among the topics that have been mentioned in the training and that you have also discussed 2 days ago during the first day of the training session, there are also other, the eutrophication, the assessing the marine ecosystem health is also another important topic. It's true that in my exercises I focus mainly on the part related on the wave energy, but we have, as I listed at the beginning, developed other training session where we were targeting also the analysis of the eutrophication through the Copernicus marine data for QGIS. So it's the scope of course of the training is very general. Then the exercises, we have the flexibility also even to differentiate, being the eutrophication already somehow touched in other training session. We preferred also to give more an outlook to the energy part that is also very interesting and relevant in the Baltic Sea. But it doesn't mean that the eutrophication is not important as well. So I encourage you to check also the other exercises and try to redo the proposed training for other region in the Baltic Sea.
Yeah, yeah, we will put the link to the tutorials catalog on the chat. Don't worry, you can see. And so the last question, and then we will move on to the last presentation. So it's more of a math question. So how different is monthly wave power density calculated from monthly means value compared to calculate wave power at hourly time step and then average over months?
Well, this is in the training. I have to admit that I gave somehow the priority to afford the problem of the calculation of the wave energy resource using the monthly climatology, because when I also, as it is described in the relevant literature, this is quite a assessed method for understanding what are the most suited area where you could install the wave energy converter. Of course, and this is somehow covering the first part of the exercises. You might have, as we can understand, when you compute the same quantity using hourly mean, hourly time step or hourly instantaneous, being the significant wave height provided as well the period as hourly instantaneous in the Baltic from the Baltic wave forecasting system, you can have more monitoring on the short-term evolution of these quantities of this P wave in the target region. So it depends on the scope of your analysis. If you are more targeting in doing an assessment of the optimal area that is more productive for an energetic point of view, and this is somehow covered by my exercise, or if you would like to have a more near real-time monitoring of the P wave in your target area, that might serve, for instance, the support to any wave energy converter installation. And of course, you will have differences because we are talking about two different, let's say, values in this case, one from climatology and another one from hourly instantaneous field.
Yes, exactly. So it depends on the work you want to do with your data.
Yeah, exactly.
Yeah. So thank you very much, Stefania, for the presentation and the questions. So I hope everyone was happy with this presentation. We will move on to the last presentation of the day, so the RStudio tutorials, and we will welcome back Alvaro to do so. So thanks again, Stefania, and welcome back, Alvaro.
Hi, again. Here we are again presenting an exercise of computing or assessment the ocean wave energy resource in the Baltic Sea. And this exercise is presented instead of using Jupyter notebooks, we are using RStudio, which is an integrated development environment of our programming language. This exercise, we are doing a similar exercise than before. And here there is, you can see here the web page of the workshop where you can find a tag called RStudio. And in this tag, you will find the contents of the workshop for this RStudio environment. But the difference is that despite of, in the case of Jupyter notebooks, we provide an environment to run the notebooks. In the case of RStudio, we are in a similar situation like in the QGIS. So you will need to download the contents, the script, and you will need to install the script in your system and run the script or the tutorial in your own system. There is not, the workshop doesn't provide an environment to run this tutorial. So in this sense, there is two buttons here in the web page where you can find all the information you can need to install this IDE, RStudio, in your computer. And also there are short video tutorial where we explain how to install this RStudio in your computer. So you have the environment to work with the RS scripts, right? In this tutorial, we also include some information for people who is not familiar with use or working with NetCDF data. In this tutorial, we are also including some information about what kind of objects are we working when we access NetCDF data. We're using R, or actually with any programming language, we are finding different objects like dimensions, variables, and attributes. So here we also give some information about how to access NetCDF data and also what information we can get from NetCDF data and how to access that information, right? Also, there is another button, which is actually the button related with the tutorial, because before we only talked about the installation of the environment you need to program, you need to run the tutorial. And here we have a button that brings you to this web page in Atlas where you can download the tutorial. As you will see, the tutorial contains 3 different elements. A folder called data, which is the folder where that contains the data you will need for this tutorial. In the case of Jupyter notebooks, we use the Copernicus Marine Toolbox to download the data. But in this case, we do not use the Copernicus Marine Toolbox. The data are already downloaded in the tutorial, so you don't need to go downloading data. You can only focus on running the tutorial and learning how to work with NetCDF data in our programming language. And also here you will find a PDF that contains the full documentation of this tutorial. Here you will find the complete documentation of the tutorial, including introduction, explanation of the use data sets, how to set up the environment of R, because you have to install some packages and load packages, etc. You will find also a section devoted to explain how to access data in NetCDF files, explaining about objects in NetCDF files, how to open NetCDF files, and also what libraries you can use. There are different libraries in R. You can find, I think, 2 or 3 different libraries to access NetCDF data. In this case, we are using, here you can see RNet-CDF, which is a library that we can find useful, very practical, and well, after this, we jump to other sections where we start to work properly with data, and we start to make plots. For example, first exercise is a very simple exercise of once we have access to the NetCDF data, we open the file and we just plot some variables, like in this case is significant wave height and the wave period. And after that, we go to compute a wave power using these two variables, and we plot this wave power density. And also we work with these plots, including some different features like the bathymetry, etc. And after that, we jump into another section where we make an analysis of the seasonal variability of wave power density. Well, here in the documentation, you can find also the introduction where we focus just in explaining this expression. As you can see, today we are talking a lot about this expression, which is the expression that allows us to compute the power density of the ocean associated to the waves. It's an expression that gives the power in kilowatts per meter of wavefront. And as you can see here, this power depends on is proportional to the squared significant wave height and to the period of the waves, right? So we will need, there are several Copernicus products that will give you this information. For example, there are reanalysis products and satellite products that will give you this information in different frequencies, using different frequencies from hourly to climatology. And well, in this tutorial, we are using, again, two different Copernicus products. We are focusing on reanalysis products. Since we have in a course of Baltic Sea, obviously we will use the Baltic reanalysis product, and we will also provide the information of how to do this tutorial using the global ocean reanalysis. And as you can see here, these tables, I provide information. You need to download the data you need for the tutorial. But as I said before, you don't need to go to the Copernicus Marine Data Store to download this data. You already have this data in the tutorial, so there is no need of going to the Copernicus Marine Data Store. But well, it's also an interesting exercise to go to the Copernicus Marine Data Store to learn how to download this data. So you can see here you have all the information you need for doing this. And as you can see here, despite of we are using two different Copernicus products, so the tutorial can be run twice. Can be run once using the Baltic reanalysis, and also after that you can run again the tutorial using the global ocean wave reanalysis. We are using two different data sets inside each product. We are using a first data set, which is this climatology dataset. This dataset contains monthly climatologies of the reanalysis, of the full reanalysis. The full reanalysis contains about 30 years of data, so work create a climatology from 30 years of data of our reanalysis. It will need valuable computational resources and memory and time. But since we can work with this previously computed climatology, we will go over this dataset using a multi-climatology, so we will be able to compute the power density, the mean power density, the total mean, and also we will be able to plot things like all the maps of power density, etc. And from this dataset, we are downloading the waves information we need, the significant wave height and the wave period. And well, this is, well, we are going to download the dates. You will see that in this climatology are referenced to 2008. Well, this is just a year of reference because the NetCDF data needs to be referenced to one in time. It needs to be referenced to one specific year, so they decide to use 2008, but this is not related with 2008. It's a climatology computed from 1890 up to 2020, right? And we are going to use also, in the case of both exercises, we are going to use also another data set that contains the bathymetry of the model we are using. In this case, the bathymetry of the reanalysis of Baltic Sea and the bathymetry of the model used for the reanalysis of the global ocean product. Well, here is explained the data sets we are using, and after that we jump in the tutorial to the, as I said before, the tutorial setup, the parts where we start to talk about the code of the tutorial, including some different codes. For example, here I give you, as you will see, there is a block of code, a cell of code devoted to load libraries we are using in this tutorial. You will see that we are not using very sophisticated libraries. And as I said before, we are using our NetCDF library as the main library to access NetCDF data. If you are interested in get more information about libraries, you can follow these links here in the documentation, where you will get all the information about, you will go directly to the main documentation, the official documentation of these libraries. We are also using plot maps to make any kind of plots, the ggplot2 library that is famous, really famous in the environment of R. And well, and from here, I will let you to explore this information, because here is starting the main tutorial, including opening how to open data files, etc. So we will go back to the presentation here. And one, as I said, we have explained a little bit what is inside of this documentation, and the tutorial also contains an R script that if you double-click over this file and you have already installed RStudio, it will open directly the RStudio, including this script, and you will find this kind of environment that probably you are familiar with it. Here you will find three different windows. In the left window, you will find access to the script we are running. And also here, the upper right window, you will see the console where you will get information of the commands run. And also here in the bottom right panel, you will find you will get the area where the plots you are making will appear. Maybe it's interesting, if you are not familiar with the environment of R, we can go directly to the case of RStudio. Here you will find this. Before I didn't explain this window because maybe sometimes it's interesting, sometimes not. So I usually click here to collapse this window. Here, as I said before, there is a console where you can type any R command. For example, you can explore the dimension of a variable, for example, in period, for example. And you can see for example, here I typed a command, an R command, so you can get the information in live. And well, to run the scripts, you can do the usual thing is to select the region you want to run, and you can push Control Enter. once it is selected, for example, here you can see you have selected this region, and this code of lines are copied here in the console and run. And if there is some kind of problems or some kind of warning, for example, here, you will get the information. And as I said before, here you have an area where you will get the plots we have created. Well, coming back to the presentation, this is the RStudio environment. And coming back to the presentation, here, as I explained it just before, you have the RStudio, and we are applying this expression, this formula, as I said before, to create this set of results. First, as I said before, we are facing a simple exercise to plot a significant wave height and the wave period in the Baltic Sea. And from here, we jump into the computation of wave power density, making this kind of plots. And as I said before, after creating the plot of power density, we work a little bit in including some other features in the plot. For example, here there is the contour lines of the bathymetry in this region of the Baltic Sea. So this bathymetry is included in the data set of bathymetry. So here we are working with two different data sets, right? And we also I haven't included here that result, but we also include the option of removing the data that is where the depth is higher of certain limit, certain threshold. We define a threshold of 100 meters, more or less. So we remove all the results where depth is higher of that threshold. And once we control the way we present the plots, including also the power density and other information, we jump into the analysis of the variability, right? Because until this point, we have worked with the mean wave power density. We have computed the mean, which is in terms of analysis of the results, is obviously interesting, but it is also very interesting to compute the variability of these results. So in the first exercise we do in the analysis of the seasonal variability is to plot the monthly maps of power density, because actually this plot will give us the tool to go to the conclusion of what months are more energetic and in which months we can expect more production and in which months we can expect a lower production. For example, here you can see in December and January, we have the more energetic months. So the production should be higher than in, for example, in June, July, where the production is the energy, the power resource is clearly lower, the minimum of the year. And well, it is interesting to know also what months are more energetic, but also I do a final exercise where we, since we know how to include in a map the contour lines of another variable, we compute the standard deviation of this monthly climatology, so we can create this last plot where we are presenting in colors the mean power density and also the standard deviation of this monthly power density. So here we can see the results of what regions are more powerful, and also what regions we can study the geographical, the spatial variability of the spatial variability of this power density, right? So we can conclude that the most energetic region here in the Baltic is the region of the Baltic proper and Gotland basin. But in terms of variability, temporal variability, we have a maximum here in the Baltic proper and Gotland basin, but also in the Sea of Bosnia, we have a maximum of variability here. So both these is our conclusion. And well, as I said before, this is the full tutorial. This is the set of exercises we are proposing in this tutorial. But as I said before, we propose to run again this tutorial using a different Copernicus dataset, so anyone can see how easy it is to, once you have access to a Copernicus datasets and different datasets, the format of different datasets is very homogeneous. You can access a dataset, and when you get the information of one dataset, you can jump or you can use any other dataset, including very few changes in your scripts and in your programs. So we use, again, we do the same exercise using the global product. We do not use the full global product, including the world, the globe. We have selected a region, a huge region here in the North Atlantic, including also the Mediterranean, Black Sea, Northwest Shelf, Baltic, the Arctic, etc. So we compute the power density for these regions doing the same exercises than before. Here, for example, here we have the power density, and in contour lines we include the information of depth of the bathymetry. And here we have the power density and the standard deviation of power density computed from monthly climatologies. And here we have, as we said before, the monthly power density computed from climatology, right? So we can see what months are more energetic and what months can be more provide more resource or less resource, right? And that's all for this tutorial. I hope you find interesting information, and thanks for watching.
Thank you very much, Alvaro, for your tutorial. It was a really nice presentation. So actually, we have currently only one question. Maybe more will come, but for now it's only one. So it's about the package. So what can we do if the packages are not downloading at the beginning of the tutorials?
Well, I would recommend to go to see the presentation of Leila. Leila has explained how to download all the data you need. So there is, with the Copernicus Marine Toolbox, maybe Leila would correct me in this sense, but using Copernicus Toolbox, you can download data using Python or using the command line in your computer. So you can install the Copernicus Toolbox in your computer, and you can use a command line to download the data you need to work, right? Actually, as Leila explained before, there is also no need on downloading data. But well, for using R, you will need to download data. Yeah. So Leila has explained how to access the data sets in a very simple way of.
Yeah, exactly. You can always check the presentation of data, and if you have questions, you can ask the user support to help you. Yeah. So that was the only question, and we don't have more, Alvaro. So I think the Earth Studio was very clear. Thank you very much. So yeah, thanks again to Leila, Stefania, and Alvaro. So we will leave in like 2 more minutes. So I'd like to have your attention on the survey. We will, thank you. So if you have like 2 more minutes of your time, we would like to ask you to fill in the survey we made for this workshop. So it would be wonderful if we could know what you think about this format of webinar and what you thought of today's session. So that can be really useful for us to improve. Before we all go, replays and presentation will be made available in the following weeks or 10 days, and you will receive an email with the certificate of participation right after the end of this event. So thanks again to all of you present. I hope you could learn a little bit more about what was Copernicus Marine Service about and what it offers in terms of data and in terms of information. and that you have learned something. So thanks again to everyone, and we'll see you in the next training session. So have a good day. Bye.